This video will look at how to do linear regression t-test to test for linearity, and also how to find your line of best fit, your R, and your R squared. I'm going to show you how to do this in your TI-83 and 84 and your TI-89 calculator. I'm going to start with my TI-89 calculator. And what I've done is I've gone into Apps and Stat List Editor, and I've typed in an X, list 1, all those X values, and then list 2, all of my Y values. In this problem, my X values are drop height, and my Y values are bounce height for some sort of experiment involving bouncy balls. So my explanatory variable, that's the thing I have control over. I have control over the drop height. My response variable, that's my Y variable. That's the bounce. After I've typed this information into my calculator, I'm going to go into test because I want to test if it's linear. I'm going to scroll down to the bottom until I see the option for linear regression t-test. By default, it should say list 1 and list 2 there for your X list and your Y list. If it doesn't, you could always hit blue and variable link to pull up all of your different lists. So blue variable link, and then I choose list 1 if it doesn't say that for my X values. I leave my frequency as 1. This means that each of these points shows up one time. And for alternative hypothesis, I'm choosing this time to test for a difference. If I wanted to test for a negative relationship or a positive relationship, that's certainly an option too. I'm going to choose to not store my regression line, although I could if I wanted. I'm going to go straight to the option for calculate. This gives me a few things. It gives me my equation y equals a plus bx. I'm going to write all this stuff down on the side, even though it might be a little bit hard to see just right now. But y equals a plus bx. It gives me a value for my a. My value for my A is 0.389. It gives me a value for my B. My B is 0.675 or so. It gives me a t-score. My t-score is massive here. It's 24.27. My p-value, very, very small p-value. That's scientific notation. That means I moved the decimal 13 places over. So I have 12 zeros and then an 8. This is a 0 plus kind of situation. I have a remarkably small p-value. I also have my degree of freedom as 14. Scrolling down, it gives me both my R and my R squared. It gives me an R of 0.988 or so. And it gives me an R squared of 977 or so. And again, the way I did this was I typed my values in list 1 and list 2. I did test. I chose the option for linear regression t-test, and it gave me all this information. It also gave me this weird spot. It gave me resid. We'll talk about that in just a second, but I want to see what I have thus far. First off, I have a p-value of 0 plus. Whenever you're doing this test and you have a small p-value, that means you reject the null hypothesis. You have evidence of a linear relationship. If your p-value is greater than or equal to your significance level, this means you do not have evidence that it's a linear relationship. So this tells you if you should be using these things to make predictions or not. Your R squared, you can think of this roughly as the percentage of variation taken by your equation. In other words, you can think of it kind of sort of like the letter grade of the equation. So this is like, it looks 97.7% like a line. This is a really good fit. It almost looks 100% like a line. I almost know where all of my variation is coming from. Finally, to get the actual equation, it gives me both the A and the B to plug into this y equals A plus bx. So my line equation is 0.389 plus 0.675 x. I'm plugging in the A, I'm plugging in the B. Now technically this line is used to make predictions, so it would be better if this said y hat. Hat means you're making a prediction for something in the future. Y means you know everything that's happened, so think of that as the difference between like p hat and p. So my equation is y hat equals 0.389 plus 0.675x. Let me show you how to do the same thing now in your TI-83 and 84. So I'm going into stat and edit, and I type my x values in list 1 and my y values in list 2. Second step, stat, I'm doing a test, and I'm choosing the option for linear regression t-test. It's going to ask me where my x values and y values are. They're in list 1 and list 2. If it didn't say L1 here, I could do second 1 to pull up L1 and so on. So all of my lists show up in these blues here. You could do blue and then that list name. I'm going to leave everything else alone and go down to calculate. This gives me my same values, my t-score, my p-value, df is my degree of freedom, gives me a, that's my y-intercept, the b is my slope, it gives me my r, that's my correlation coefficient, and my r squared, that tells me how good the fit is. It looks 97.7% like a line, roughly. So that's how I use my calculator to come up with everything at once. I could have also done F5 for calculate or gone into the calculate option and scroll down until I see linear regression AX plus B. And this would give me the same line, but it doesn't give me as much information as that linear regression t-test. It doesn't give me the t-score, it doesn't give me a p-value, and I'd have to change a setting in my calculator to have r and r squared show up. So I would strongly recommend using linear regression t-test. It gives you significantly more information, and it makes you just that much more deadly when it comes to statistics. This is it for linear regression. I will still make a few more videos here to try to help you out with some other topics, but this is it for today.